We're going to now look at the rational zero test and the rational root theorem. You're going to notice different wording on questions that some are going to say, find me all the possible rational roots. Now this is a technique that's going to find you all the things that could possibly work. It's not saying it's the actual amount of roots. So you have to accept that there's going to be more than the power of the function. So first thing you're going to do is identify the constant and the highest degree coefficient. And then you factor both of these. And then the constants factors go in the numerator, and the coefficients factors go in the denominator, and then we go and sort through our options. So let me show you what that looks like. So I start here, I identify my coefficient of 2, I identify my constant of 3. The factors of 2 are 1 and 2, always a good day, and the factors of 3 are 1 and 3. So the constant is going to go in the numerator, and then the coefficient is going to go in the denominator. And then you're going to just look, okay, 1 divided by 1 is 1, 3 divided by 1 is 3, then 1 divided by 2 is 1/2, and 3 divided by 2 is 3 over 2. And the last thing we have to be aware of is that possible factors could be plus or minus, so you want to put a plus or minus in front of the whole set, okay? So here we go. Let's try one more. So first, you have to notice, oh no, the 4 is on the wrong side. So we'll just rewrite it real quick here. Subtract that 4 over. Identify that's your constant. Identify the 13 is your coefficient. Factors of 4, 1, 2, and 4. Factors of 13, 1 and 13. So now you're going to go ahead, you're going to put the constant on top. 1, 2, 4 are options, and the bottom is 1 and 13. And then I just look at each possible one again. So we have here 1 divided by 1, and then 2 divided by 1, and 4 divided by 1, and then go through and divide by the 13. So 1 divided by 13, 2 divided by 13, and 4 divided by 13. Perfect. Again, remember that's plus or minus for all your options. Here's a wonderful one for you to try. Make sure you put everything on one side. Pause the video. You should end up with 1, 3, 5, 15, 1/5, 3/5, and again, you need to have that plus or minus in front. Okay, the next step is finding all the possible roots, rational roots, and then going on to solve it. So the first thing I want to go here, let's see, blue marker. I'm going to start, identify the coefficient, over here the 6, and the constant the 5. So I've got nice 1 and 5, 1, 2, 3, and 6. That's going to take a little bit longer. So now we're going to go ahead. In the top is the 1 and 5, and in the bottom is the 1, 2, 3, and 6. So here we go. 1, 5, 1/2, 5 over 2, 1/3, 5 over 3, 1/6, and 5 over 6. Okay, and remember all of those options are plus minus. So woohoo, that was a lot of fun. Now we have to decide how we'll know which ones are the actual roots. So your options are 1, going ahead and doing synthetic with all of those options. You'll know that it is a correct choice when you get a last term of 0. That could take some time. Second, plug in. We talked about the root theorem. You can plug in. If it equals 0, ta-da, you've found it again. Or third, use technology if you've got it and graph it to see where it hits the x-axis. So doing that, I find out that one of my roots is going to be 5. So I'll put that right up here, and we'll do 6, negative 31. I need to leave a space. No, I don't. I'm fine. 4 and 5. Sorry about that. Put a line, drop the 6, add our multiply 5 times 6, get 30. Add, and I will get negative 1. So that's negative 5, a negative 1 again. And there we go. So 6x squared minus x minus 1 equals 0. And you might be already grossed out, and that's okay. You can use the quadratic. I'm going to go ahead and try to factor it first. So knowing that these have to be 1s, I'm going to break this into 3x and 2x. I need a negative 1, so I'm going to multiply the 3x and the 1, make that a negative 3x, and then inside here that will be a plus 2x. So then I just set each one equal to 0, and I get negative 1/3 and positive 1/2. Number 4, I'd like you to try. So go ahead, work on that right now. So your possible roots are going to be 1 plus or minus, 1, 3, 9, 1/2, 3 over 2, and 9 over 2. You will then find out the actual roots are negative 1/2 and plus or minus 3i. The last thing we're going to do in this video is look how to put this stuff back together. So if I've divided by some kind of binomial, I end up with a certain polynomial, and it'll usually have a remainder. How do I put it back together? Well, the opposite of division is multiplication, right? So I'm going to show you 2 different ways to set these up, and you can pick the way that you like better. First, way back in the day when you first learned multiply, we set things up that we lined them all up. And first I'll multiply by the 1, so that's easy. 4 minus x plus x squared. And then we know when I start the second term, the 2x, I'm going to put it under that. So 2x times 4 is going to be 8x. 2x times negative x is negative 2x squared. And then 2x times x cubed is 2x cubed. So go ahead, 2x cubed minus x squared plus 7x plus 4, and then add your remainder of 3. So you'll have an answer of 2x cubed minus x squared plus 7x plus 7. Okay, the other way you can look at it is, if you want, is just more of an extended FOIL method here. Really, it's just double and triple distribute. So start with the x squared times the 2x will give you 2x cubed. And then do negative 3x times 2x will be negative 6x squared. And then 1 times 2x will be 2x. Then redo the whole thing with the 1. So x squared times 1 is just x squared, always nice. Negative 3x times 1 is negative 3x plus 1. So I'm going to multiply, or now I'm going to combine like terms. 2x cubed, and then I have minus 5x squared minus x, and then I have a 1 and a remainder of 5, so that gets me up to 6. Here's 2 examples for you to try. Go ahead, pause the video, and I will write the answers up there for you. Alright, so the top one, here we go, is 3x cubed plus 4x squared minus 13x plus 5. And the bottom one is x to the 4th minus 2x squared minus 1. Have a great night.